Good day, everyone. Welcome to the virtual world of learning. I am Rodville Esquezan, and I am with Mr.
Ruben E. Magdon Jr.
And we are the reporters of Graph Coloring. So at the end of this topic, we will be able to understand the concept of graph coloring, and also we will be able to apply the theories to graph coloring. So what is graph coloring? Graph coloring is a process of assigning colors to the vertices of the graph, such that no two adjacent vertices of it are assigned the same color. So graph coloring is also called as vertex coloring. It ensures that there exists no edge in the graph whose end vertices are colored with the same color. Therefore, such a graph is called as a properly colored graph. Now, obviously, this is an example of a properly colored graph. So, in this graph, no two adjacent vertices are colored with the same color. Therefore, it is a properly colored graph. Now, at this point, let us proceed to the two theorems, which are the two colorable graph theorem and the four colorable graph theorem, and which will be presented by Mr. Hagdon Jr.
The two colorable graph theorem states that a graph is two colorable if and only if it has no circuits that consist of an odd number of verticals. The following graph is two colorable. So based sa gipakita dira na graph, aton makita if aton iapon ang mga circles sa graph, aton makita aton na siya iapon 2, 4, 6, 8. So aton makita nara siya 8 ka circles. So dili siya naton matawag na odd number. So even number siya. So matawag siya naton na two colorable graph. Ang sa two colorable graph kay dapat lain-lain ang iya color. Sa first circle, for example, red. The next circle is blue, red and blue not. Kay nagpasunod man sila, nagconnect man sila sa usa't usa. So amin na example sang two colorable graph. Tag-aton lat mandaan if even number gani, amin ato siya matawag na two colorable graph. Another theorem is used to color graphs. This is known as the four-color theorem. Instead of coloring the verticals, the regions of the graph are colored. The four-color theorem states that at most four colors are needed to color the planar graph, such that no adjacent regions share the same color. The following shows this. Sa aton makita, ang graph na example is dili siya parehas ang color, di ba? So may siyang example sang the four-color theorem. So, that's all for two theorem.
Okay, to continue this topic, let us have the chromatic number of the graph. But before that, let us know first the concept or the definition of chromatic number. So, what is a chromatic number? So, chromatic number is the minimum number of colors required to properly color any graph, such that no two adjacent vertices of it are assigned the same color. Now, as you can see on the screen, this is an example of a graph which has a chromatic number of 3. So, in this graph, no two adjacent vertices are colored with the same color, and the minimum number of colors required to properly color the vertices is equals to 3. Now, meaning to say, we cannot properly color this graph with less than 3 colors. This time, let's proceed to the chromatic numbers of different graphs. So first, we have a cycle graph. So as you can see on the screen, a cycle graph is a simple graph of n vertices, which is n is greater or equal than 3, and n edges forming a cycle of length in n is called as a cycle graph. So in a cycle graph, all the vertices are of degree 2. So the chromatic number of a cycle graph Meaning to say, if number of vertices in cycle graph is even, then its chromatic number is 2, of course. Now, if the chromatic number or the number of vertices in cycle graph is odd number, meaning to say, its chromatic number is equal to 3. Now, this is an example of a cycle graph which has a chromatic number of 2 and on the other side has a chromatic number of 3. Now, the next graph is a planar graph. So a planar graph that can be drawn in a plane such that none of these edges cross each other. So chromatic number of planar graphs is less than or equal to 4. So an example of planar graph, all cycles are all planar graphs. The chromatic number of each graph is less than or equal to 4, as I said earlier. So the next graph that we're going to look into is the complete graphs. So complete graphs is a graph in which every 2 distinct vertices are joined by exactly one edge. So in a complete graph, each vertex is connected with every other vertex. So to properly color it, as many different colors are needed as there are numbers of vertices in the given graph. So chromatic number of these complete graphs is equal to the number of vertices in that complete graph. So this is an example of a complete graph. So let's proceed to the other type of graph, which is the bipartite graph. So a bipartite graph consists of 2 sets of vertices, which is the x and y. So the edges only join vertices in x to vertices in y, not vertices within a set. So meaning to say, the chromatic number of any bipartite graph is equal to 2. So this is an example of a bipartite graph which has a chromatic number of 2. So meaning to say, all bipartite graph has a chromatic number of 2. So the last one is the tree graph. So a tree is a special type of connected graph in which there are no circuits. So every tree is a bipartite graph. So chromatic number of a tree, which any number of vertices is also equal to 2. So meaning to say, tree has a chromatic number of 2. So in this topic, all you need to do is to ensure that there exists no edge in the graph whose end vertices are colored with the same color. So that's all for graph coloring. Once again, I am Rodwell Esqueza.
I'm Robeni Magno Jr.
And we hope that you learned something.